Alright, here we are for the Chapter 6 kind of notes overview. Now, we're not going to necessarily explain, we're going to explain, but we're not going to be as in-depth as we would be in the lecture. And I'll post kind of supplementary Khan Academy videos because really I think they do a great job of explaining these basic concepts. So this is more so intended to be just your guide through the examples that we did in notes together, just to clarify or re-reason. But I guess with that being said, let's dive in. So we're not going to fill out those top sections or things. I think I've uploaded those from what we did in the lecture together. So let's just dive in and see what we can do. So the greatest common factor and we're going to look at each term individually. So step one, and we're going to build our steps as we go, is we're going to start asking, for each question, what should I be looking for? And for every question, the first step is there a common factor? So between 4 and 28, do they share anything? Well, they actually share 4 itself. 4 can divide into both of those cleanly. What about your variables? So for your x's, there's an x squared, there's an x to the first. Can you take at least 1 or 2, or how many x's can you take out? Well, they at most share 1x, so I can take that out. And now I'm going to do what we just ended. I guess I say we just ended, but I just ended because I'm recording these back to back. But we just did division in the end of chapter 5, so I'm now saying I'm taking this 4x and I'm dividing it out. So 4x squared divided by 4x, well, 4 divided by 4 is 1. X squared divided by x leaves me with 1x, and so I'm done with that. Or in other words, if I re-multiply this or distribute it, I'd get back to 4x squared, so I know I did it right. Negative 28 divided by 4 is negative 7. X divided by x is 0 x's left over, and so there we go. This is my right answer. Now, remember that factoring means you're writing this multi-term expression into its smallest components. You're breaking it down in some way. Factoring ultimately means dividing things that were multiplied together, right? Maybe this is the one example we'll do. For 30 breaks down into, 2 and maybe 15. That's one way to think about it. There are multiple ways to think about that. But then it breaks down to 3 and 5. But now each of those numbers, if you've learned some fancy words, are prime. So 2 can only break down to 1 and 2. 3 can only break down to 1 and 3. 5 can only break down to 1 and 5. So 30 is essentially composed of a 2 times a 3 times a 5 as prime factors. And so that's what we're doing with this ugly algebra, is we're saying, what are the smallest components I can break this up into? And you'll have to take college algebra to see the magic of being able to break those down. You'll actually be able to see a lot of what this graph looks like based on the fact that this breaks down to a 4x and an x minus 7, and you'll learn behaviors of graphing just from being able to split it into its smallest parts. So how do you know you're done? Well, because my inner parentheses, I'll start to refer to those as the leftovers, can't be broken down anymore. A 1 and a 7 don't share anything, an x and nothing with an x, they don't share anything, so I know I'm done. Good to go. Okay, also one way I know it's done is we call these, one more explanation. I said I wasn't going to explain, but here I go. These are what we call linear factors, because there's an x to the first and then maybe just a number. And as long as you're breaking down things into linear factors, there's nowhere lower they can go. So that's your other hint in most cases. Let's keep going, though. This next example, there's definitely a 3. And do they share any a's? Well, this has a squared, but this has no a's. So no, they actually just share the 3. And so even though this isn't a linear factor, I guess this would be where later on we'll say, whoa, let me think. I see a a squared and a minus 3. Is there anything I can do with that? But for now, just know that there is not. Okay, up next, hopefully we see it, 7x. So we're left with x squared plus 2. Your best bet also, just to say, is how do I know I did it right? Redistribute it. Hopefully foiling and redistributing is really easy mentally. So 7x times x squared is 7x cubed, check. 7x times 2 is 14x, check. It's almost like what you're doing is you're almost guessing, you're doing some work, but you're saying, let me write this down and then let me try to redistribute it. Is it that thing? Great, move on. Is honestly the way I almost think about it at this point. So 18 and 3, those share 3. A b to the fourth and an ab share at least a b. So I'm left with 6b cubed. Careful that your 6's don't look like b's, like mine do. And then that would actually just be minus a, because the 3 and the b left, and so only a is left over. Once again, check, refoil, but it works. Alright, up next, these at most share a 5. They don't share any k's because that 10 doesn't have a k, so now k's are out of the running. So we're left with k squared minus 8k plus 2. Alright, we're doing quick division here, but always, in this section, I think I'm going to move a little faster, especially in some of the earlier parts. We'll explain the parts we need, but, doing this division, that's a stop, pause moment where you go, wait a minute, where did that come from? Well, we're dividing it out of each term, but now I'm talking, and so now, anyways, we're going to move on. So, up next, one thing we want to know is that we never want our leftovers, as I'm going to call them, the things that end up in parentheses after I find my common factor. We never want our leftovers to begin with a negative. So, when I look at 24, 36, and 60, number one, you might think small and think, oh, these all at least share a 2. Or maybe you notice they all share a 3. Or maybe you notice they all share a 4. But actually, the most they share is 12 itself. But because we never want to lead with a negative with our leftovers, we're going to take out a negative since this led with a negative, so that my leftovers will double negate and begin with a positive. Now let's look at the other variables. I see a squared, a, and a, so they share at least an a. I do see a b squared and a b, but there's no b on this last term, so I can't say that b is shared. Alright, we are left with positive 2ab squared. We're left with negative 3b, and we're left with positive, I think that'd be 5, just 5 itself. Again, your best check there is redistribute it. That is negative 24, that is a squared, and b squared was already there. This is positive 36, a and a b. This is negative 60, and a single a. And I know I'm done because 2, 3, 5 don't share anything. There's an a here, but nowhere else. There's a b squared b, but no other b. So I know I'm done. So the thing we wrote down in the notes, you'll see it in the online upload, is that we never let our leftovers, the parentheses left over after finding the common factor, begin with a negative. Take out a leading negative. It'll switch all the signs inside, but that's okay. We can always redistribute and get it back. All right. Up next, let's see here. I see a 5 shared. X cubed, x, and x, there's at least one x shared. A y cubed, and a y, there's at least one y squared shared. And so I'm left with x squared. When I divide that out, it redistributes back to the x cubed and everything else. I'm left with a 4 and a y squared. And I'm left with a just minus 2. Again, my check there as I work it through is I'm redistributing in my head. Hopefully through this class you'll learn to distribute things in your head mentally really quickly. Now number 8 is where things really pick up, so to speak. And we're going to start asking ourselves, what's the thing that's shared here? This one's a little special. It's got 2 things going on here. So let's deal with the most glaring thing. Although this looks like many terms, there's really only 2. Because there's a 10 multiplying to something. There's a negative 5x multiplying to something. A term is a collection of things multiplying together. So there's term 1, there's term 2. What's the most obvious, or maybe the most unintuitive thing I see they share? It's actually the x plus 2. The x plus 2 in parentheses is what's shared. So this looks awkward, but think about it. If 5 and 20 and 10 all share a 5 and I can take it out, then if this term and this term share the x plus 2, and I can see it literally in front of me, then I can factor out that x plus 2, and I've got my leftovers of 10 and negative 5x. Now here's the issue though. This time we're not done, because look at this linear factor. When I look at 10 and negative 5x, they actually share a 5. And so what I can do is, because we're multiplying, I can take out the 5 and not just put it right here in between, but move it all the way out front, because multiplication can be done in any order, and see that I'm left with 2 minus x. Now, in other words, I think what we're saying here is, at the beginning, you could have noticed that the 10 and the 5x already shared the 5, and you could have taken that out at the beginning. But I really wanted, in this one example, because it's going to show up a lot in the future, is when you notice there's a parentheses with something in front, a parentheses and something in front, but that parentheses is the same, that parentheses is your common factor, and you're going to write your leftovers. That's the other thing that, again, people will get confused at later on, is they'll start saying, why are you creating this other set of parentheses? Because look at what we did up here. When we find our common factor, we create a set of parentheses for our leftovers so that the common factor will distribute to all other parts. So that's what we're doing here, is we're saying, there's my common factor. I'm rewriting my common factor. It had parentheses, so I'm rewriting my common factor with its parentheses. And then I'm creating a new set of parentheses for the leftovers. So all these examples flow the same. Hopefully that catches and clicks. Hopefully it does, because the next examples are going to take advantage of that rule and that idea. So here we go. So when we're in this course, essentially anytime you see a 4-term problem, you're going to be doing some sort of by grouping. And so here's the by grouping technique, is when you see 4 terms, think about them 2 at a time. So first 2, last 2. For the first 2, find your common factor. There we go. So for the first 2, 8 is shared by both, and then r squared is at least shared by both, and so we're left with r minus 8. Again, leftovers go in parentheses. Now, here's the interesting thing, is the second question is technically the same. What is the greatest common factor? The other question is, or the other way to phrase it, which we'll say more often, is how do I make these match? Now, we're in a rare case, but it's the first one we saw because I wanted to say it early on, is that they already match. So we need to take something out, but what do they share? Well, nothing, but anything times 1 is still itself, so we can actually just factor out a 1. And that will matter now, because here we are in this next example, but it looks oddly or exactly like the last example, where now the parentheses are the thing that's shared. So I factor out that r minus 8, the common factor. I create a parentheses for my leftovers. And what are my leftovers? The 8r squared from here and the plus 1 from here. And the short answer is, you need that plus 1, because if you don't write the plus 1, you don't refoil out to all 4 terms. You wouldn't be foiling, because there is no extra term to have a binomial and a binomial. So you need, if you don't have a match, you need to take out a plus 1, or sorry, let me rephrase. If you already have a match, you still need to take something out, and in that case, it'll be a plus 1. Okay, let's look at the others. So, 2 terms for a total of 4. Again, when you see 4 terms, you're going to be doing by grouping. So, for the first 2, 12 and 21, they at most share, I think, 3. And p cubed and p squared share at least p squared. We're left with 4p. We're left with negative 7. The next question, again, is technically the same. What's the common factor? But really, it's how do I make a match? What can I do to 28 and 49 to get 4 and 7? Well, it's actually divide out a positive 7. And I would be left with 4p and negative 7. So I got my match. Now right here at this point, again, you should technically stop, pause, and refoil out right here, redistribute out. 3p squared to 4p, yep. 3p squared to negative 7, yep. 7 to 4p, yep. 7 to negative 7, yep. Now that I did that though, look at these two new terms. What do they share? They share the parentheses 4p minus 7. Create a parentheses for your leftovers. There's a 3p squared and a plus 7. At that point, I think we've got the concept, but let's just do the other three because that's what this video is all about, being a guide for your notes. So they share 2x squared. You'd be left with 6x plus 1. How do I make a match out of 6x and plus 1? I would take out the negative 5. Again, our leftover should never lead with a negative anyways if we're finding the greatest common factor. And so I'd be left with 6x plus 1. I got my match, so to speak. So now I share the 6x plus 1, and I'm left over with the 2x squared minus 5. Alright, onward still. First two, it looks like they share a 9 in n squared. It'd be a 7n and a plus 6. So here's one thing that can help when the numbers get large. I know that 105 should turn into 7. I know that 90 should turn into 6. So you can actually do some fun tricks. Fun's relative. But you can actually do a trick here where instead you say, well, what is 105 divided by the 7 I should be left over with? And it's 15. And what is 90 divided by the 6 I should be left over with? 15. So now I know that the thing that 105 and 90 share is 15, and it needs to be negative to get my match. There is 7 left over and 6. So that was kind of interesting, right? We saw 15 come out of the division of 105 divided by 7, 90 divided by 6. So we got 15 for both, so we know 15 is the greatest common factor of those two numbers. We know that 15 is the thing we need to make our match. We need to take the negative out so they both turn positive so we truly have our match. Now that we have our match, the match is the common factor of those two terms. The leftovers get put into parentheses. And we're good to go. Alright. Last one, but it looks a little uglier with all the variables, but that's fine. We can still handle it. 56 and 49 share a 7. X and X share an X. But W doesn't have a match, and there's no K, and there is a K squared. So 7X looks like our greatest common factor from the first two terms on the left. We'd be left with 8W. We'd be left with 7K squared. So now I'm looking for 8 and 7. Looks like I could divide out a negative 3. Looks like I'm looking for W in K squared, so I could take out the Y. Whoops. Should have left some space. So 3Y. And I would be left with, yes, my positive 8W, and I would be left with, yes, positive 7K squared. And again, before you just move on, stop, pause, double check. That does make 56x with a W. That does make 49x with a K squared. That does make negative 24y with a W. That does make negative 21y with a K squared. So I know I did it right. And now, again, the argument is the 8W in parentheses with the 7K squared is my common factor. My leftovers get put into a newly created parentheses. And we're done. Alright, so that is factoring by grouping factoring, where if there's 4 terms, you split the first two and the last two, GCF, GCF, you end up with a matching pair, and that matching pair is what's factored out, and your leftovers go in parentheses. Okay. Now, that takes us into factoring trinomials, and the thing here is there's not 4 terms, but we can turn this 3-term structure into 4 terms if we can find some magic numbers. Alright, now as this is review, we're going to start to build up every question we should ask not just what do we see or what are we learning in this technique. So here we go. Does x squared, x, and no x share anything? No. Does 1, 9, and 14 share anything? No. So then we're going to ask a different question. Okay, from there, what is 1 times 14? Well, that's positive 14. You write it down. What are the factors of 14? Well, 1 and 14, 2 and 7. And we're done. Now, I'm always going to write the factors of that number in that order. 1 in the thing. Does 2 work in that thing? Does 3 work? No. Does 4 work? No. Does 5 work? No. Does 6 work? No. And I end up with 7 works, but I already wrote it down, so I know I'm done. So on the left-hand side, I'm always going to go sequentially in order if I can, and write its matching pair that will get me 14. But from there, the idea is I'm writing down that plus sign. When I do my 1 times 14 and I get positive 14, I'm going to write down the plus because I'm looking for factors of 14 that add to that middle number. Well, 2 and 7 add to that middle number. And so here we go. We're going to do this the long way. What you do is you take those two numbers, 2 and 7, and we split 9x into 2 and 7. Now 9x has an x, so the 2 should have an x, the 7 should have an x. I need to recreate positive 9 from these two based on the fact that the factors of 14 had to add to 9. So 2 and 7 need an x, and they need to make this positive 9. How are 2 and 7 going to make positive 9 if they're both positive? So I've just assigned them signs. At that point, you've done the heavy lifting, because look at this, we're just doing by grouping now. These share an x. I'm left with x plus 2. What do these share? Or how do I make a match? I take out a 7. I'm left with x plus 2. What's now shared among them? The x plus 2 and the x plus 7 is the leftover, so they get put into their own parentheses. Done. Now, from there, what I am going to do is I'm going to be lazy and say, if you identify plus 14 and you write down 2 and 7, as long as you put the 2 and 7 when that first number is 1, sorry, I should have said that, when the first number is 1, and you identify these two numbers, they end up being in parentheses with their appropriate signs. And so although if you were in class you saw me do by grouping a lot, I'm not going to do that because if A is 1, you really shouldn't write the full by grouping, but it's good for when by grouping is necessary. So here we go. 1 times 12 is negative 12. What are my factors of 12 that subtract to 4? Let's find out. There's 1 and 12. Those subtract to make 11. There's 2 and 6. Those subtract to make 4 in some way. So those are my pair. Although there is 3 and 4, you know, I don't need those because I already found a pair that will make 4 by subtraction. Again, that minus sign right there, 1 times negative 12 is negative 12. The negative has an impact because these two need to subtract to make 4. 3 and 4 subtract to make negative 1 or 1. 1 and 12 subtract to make 11 or negative 11. But only these two subtract to make 4 or negative 4. Now because of that, because of what I said, I'm going to jump right to my parentheses. There's a 2, there's a 6. What are the signs? Well, I need to make a negative 4 out of 2 and 6. So 6 needs to be negative, 2 needs to be positive. Now, there are rules about, or there are things that end up being true about if there's a negative at the end, the signs are opposite. If there's a positive at the end, the signs are the same. And are they both positive, or is one negative, one positive? I'd rather you not memorize those 2 extra rules and rather just say, hey, 12 that subtracts to 4 is 2 and 6. And then think, how do I recreate negative 4 out of 2 and 6? That shouldn't be too hard of a problem in our intermediate algebra or college algebra class. So we're just going to think of those simple problems. We're not going to memorize, you know, positive means same, subtraction means opposite, although I'm saying that for you. If you like that and that works for you, great. We should more so think about these as fun little easy problems in the middle of what we're doing. Now also the other thing I'm going to say, but we're not going to do it here in this video, is of course refoil these out and see that you do make x squared. You do, from the foiling and combining like terms, make a 9x in the middle and get your 14. Refoil this out, because now I didn't show you the by grouping process, but it is true that you will foil this out, and by combining like terms you will have a negative 4x and a negative 12 at the end. We're going to move faster though. 1 times 15 is positive 15. The factors of 15 are 1 and 15, and 3 and 5, because 2 doesn't work with that. You would get a fraction. So we're only worried about nice clean factors. Now from there, which one of these will add, because there's that sign, to make 8? Well, 3 and 5. I can jump right to my parentheses because a is 1. Again, in lecture I did not do this. We did by grouping over and over and over again. You should do it to see why. Maybe we'll do that on 1 because I can't help myself. But up next, how am I going to make negative 8 out of these two numbers? Well, they're going to need to combine to make a negative 8. They're going to both need to be negative. Foil it out, see why. Try it with both of them being positive. Try it with one being positive, one being negative. But really, more so, think about it as a silly little question. How can you make negative 8 out of 3 and 5? Well, they both have to be negative. That's the only way. And then look, if negative 3 times negative 5 has to happen, you make positive 15. That's where the plus comes from. And that's the last time I'll say, if it's positive at the end, or maybe not positive at the end, but if your multiplication ends up having a positive, then they both will be the same sign. Look at that. So there you go. All right, let's go quicker. 1 times 12 is negative 12. How will I subtract to make 13? This is a fun one. Well, there's 1 and 12. Those subtract to make 11. There's 2 and 6. Those subtract to make 4. There's 3 and 4, and those subtract to make 1. And, well, 4 would go next, but 4 is already represented over here, so I'm already done. I've listed everything out. So what factors of 12 subtract to make 13? And that's why that symbol matters so much. The answer is none. So we say that this polynomial is prime, and it can't be factored. So, not every question you see can be factored. Be careful of that. Speaking of being careful, I do have a typo. That should be a 16x. So factors of 60 that add to 16. I'm going to move even faster because 1 times 60 already I knew is 60. I already recognize that a is 1, so I can jump to my regular factoring, so to speak. Also, factors of 60 that add to 16 are 6 and 10. I don't need to list out all the factors if I know what they are ahead of time. It's just a nice practice if you're learning the skill. They both need to be positive to make a positive 16x in the middle, and they'll need to both be positive to make positive 60 in their final multiplication in the foiling process. Again, foil, foil, foil. I can't emphasize this enough. Refoil your work to understand where this result is coming from. If you don't refoil it, you're going to miss the magic of really seeing how those numbers are playing with another and how I'm able to do this so quickly as I go through it with you. So, speaking of quick, factors of 11 that add 12 are 1 and 11. They both need to combine to make negative 12 in the middle, so they're both negative, and I know I'm right. That should be about the time it takes with practice to go through one of these questions. But now, as quickly as we were going by the end there, we now are slowed down because finally this first number is not 1, so we've got something interesting on our hands. 2 times 2 is positive 4. The factors of 4 are 1 and 4, 2 and 2. Which one of these pairs will add to make a 5 in the middle? 1 and 4. This is where we do the true process. In other words, this is where I know I shorthanded 1, 2, 3, 4 examples. All 4 of those could be done by splitting the middle, like I did, going through the whole process, but now I'm going to have to, because when a is not 1, you're going to need to write out that splitted middle into the 1x and the 4x, according to my circle here, and the plus 2, in order to see the correct final answer. And so, how do I make negative 5 out of these? Well, they're both negative. And what do I do now? I do regular by grouping. These share an x, I'm left with 2x minus 1. How do I make a match? I need to take out a negative 2, and I'm left with 2x minus 1. Now what's shared is the 2x minus 1, and what's left over is the x from here and the negative 2 from here. Remember, your leftovers get put in a created new parentheses that wasn't there before. And I know in the middle of that process, and I gotta go back to it, I know in the middle of that process you go, whoa, 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 where'd the parentheses come from? But everyone's fine with it right here. When I took the 4x out of these two simple terms, the parentheses was created for the leftovers. So if 4x comes out of both of these, then write the 4x and create a parentheses for anything left over. Similarly, again, just to re-emphasize it, if you've been skipping through the video, and that's fine, but if the 2x minus 1 is what's shared, it goes out front, and the leftovers get put in a newly created parentheses, just like before. Alright, let's keep going. 3 times 4 is 12, positive 12. So I write down 112, 2, 6, 3, 4. 4 would go next, but 4 is already there, so I know I'm done. Which one of these will add to 13? 1 and 12. When I write those down, I can't cut to my parentheses like before. I have to split the middle. And just saying out loud, that's what I should have been doing on all those other examples, but you can cheat, quote unquote, and jump right to parentheses. But not with by grouping, you won't see 1 and 12 at the ends. So let's see what happens. The x is shared. I'm left with 3x plus 1. Now how do I get a match? I take out a 4. And I'm left with, 3x plus 1. So notice that these ideas are building on each other. We've talked about what do I need, how do I get a match. It's now showing up over and over. I really need it here, but I'm not going over it in depth because that should be practiced earlier. You should honestly do 2, 3, 4, and 5, and 6 with that whole write it out and split the middle and do the whole by grouping like we did in number 1. And over time, you'll learn to see when can I skip to the parentheses? Oh, when there's nothing in front of x squared. And when do I need to write everything out? Well, when the number in front of x squared isn't 1. Alright, let's keep going. 7 times negative 45. Uh-oh, this is negative 315. This one's hard to break down. There's 1 and 315. 2 doesn't work, and that shouldn't be surprising because they're both odd numbers. But 3 works. 315 divided by 3. 315. Well, I said sorry, but it's on my calculator. Did I say 315? 1 minute. Yeah, no, it's 315. Sorry. 315 divided by 3. I'm trying to go too fast in my calculator. Is 105. Up next, does 4 work? No, and that's not surprising because this is an odd. But 5 works. 315 divided by 5 is 63. What about 6? 315 divided by 6. That doesn't work. 315 divided by 7. Well, 7 times 45 is where we got this from. Let's keep going. Does 8 work? No. Does 9 work? 315 divided by 9 is 35. Goodness. Does 10 work? No, because it doesn't end with a 0. Does 11 work? 315 divided by 11. Nope. Divided by 12. Nope. Divided by 13. Nope. 14, 15, 315 divided by 15. I think that works. I've got 15 and 21. I think I might be done here. And also, let's stop and show you how I know I'm done. Because I need to subtract 35. These subtract to 314. These subtract to 102. So they're getting smaller. These subtract to 57. These subtract to, ooh, we're getting close. These subtract to 38. And then these subtract to, let's see, 26. We've skipped over 35. We went from 30, I think 8 to 26. 35's not there. These subtract to 6. This is another example where it's prime. It's a bummer to go through that, especially when there were so many options, but if none of them subtract to make 35, then there's nothing left to do in this question. Alright, we'll skip over number 10. I don't want to introduce an equal sign just yet. Alright, number 11. Maybe that was meant to be a minus. I don't know, whatever. Anyways, number 11. 2 times 1 is 2. Thankfully, there's not many factors there. 1 and 2. And that is a positive 2 from that multiplication. So let's split the middle, because those will add to make 3. And there's the plus 1 at the end. They'll both need to be positive. 2 groups, n is shared. 2n and 1 is left over. I already have 2n and 1. There's another example, but I need to write a plus 1. Now the 2n plus 1 is shared, and the n and the plus 1 that already matched, but I needed to take something out, is my leftover. Alright. We're doing good so far. Let's keep on going and see how it goes. 3 times 8 is 24, positive 24. There's 1 and 24. 24. There's 2 and 12. There's 3 and 8. There's 4 and 6. And I'm done. Which one adds? Adds, because 3 times 8 is positive 24. Which ones add to make 10? 4 and 6. So we once again split the middle. How do I make negative 10 out of these two? They're both negative. And so we ask, what do they share? Well, these share an x. And these share a negative 2 to create a match. Now what's shared among them is 3x minus 4. What's left over is the x minus 2. Alright, we're doing good so far. Oops. We're doing good so far. Let's see where we go next. Alright, from there we've got a lot more by grouping examples, and I think what I'm going to do for this video, because we have the other stuff in lecture, I'm going to skip over some of the more basic stuff. I'm gonna skip over 13 and 14. I know we went over those. And we're going to cut down to 15 through the rest, just for sake of time, just to see what we can do. So what I want to do is I want to now kind of talk through everything, because we're going to see some stuff show up. So we're going to treat these last 8 examples as everything we need to consider before we learn more rules. So first, x squared, x, no x, and then, so there's no x shared, and then 1, well, at that point, 1 doesn't go into anything else. So we're still doing regular factoring. A is back to 1. Let's do by grouping one more time, even though we don't need to, just to review it, because I want to. Those don't add to make 12. 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 5 doesn't work. But those add to make 12. Alright, so by grouping says, if you see 3 terms, you can create 4 terms. That's what we've been doing every time. There's an x and an x that I need to make negative 12, so they're both negative. What do they share? They share an x. How do I make a match? I take out a negative 6. Double check, again, x times x is x squared. Yep, there it is. X times negative 6 is negative 6x. There it is. Negative 6 times x is negative 6x. There it is. Negative 6 is positive 36. Yes, there it is. So now what's shared? That parentheses x minus 6. What's left over? The x from here, the negative 6 from here. I get a perfect match. This is going to show up in 6.3. Now again, this is finally where I said, or what I wanted to do in this one example is say, hey, when a is 1, when that number out front is 1, if you find 6 and 6, you're ready to go right to your parentheses. That's not true for the others that we've seen. All right, 16, you might already start doing by grouping, but wait, 3, 18, and 24 share 3, n cubed, n squared, and n share at least an n, so we finally have a common factor. Plus 8. All right, from there, now we're looking at our inner parentheses, and that's what we're going to deal with factoring. So what multiplies to 8 and subtracts to 6? Sorry, adds to 6. I didn't take out a negative. What multiplies to 8 and adds to 6? Well, 4 and 2. Once again, because a is 1, I can jump right to my parentheses, so I'm back to doing the quick work. There's an n, there's a 2, there's an n, there's a 4. Those multiply to make 8. They can add to make 6 if they're both negative. So, when you have a common factor, when you identify a common factor, it tags out front, and now you treat the inner parentheses as its own little problem to take care of in factor like normal. All right, let's see where that takes us. Next example, there's a 12 shared. Leaves me with x squared plus 4x plus 4. From there, what are the factors of 4 that add to 4? Well, 2 and 2. And just to say, mathematicians are lazy, so you could write this as that, because we wrote the same thing twice. Alright, we're doing good. We just have 5 more examples for this video. We'll continue the rest of chapter 6 in the next. What we can do now is we can remember that we should never have a leading negative. So my first step, even though there's just a negative 1, is still to take out the negative entirely. From there, what are the factors of 12 that add to 13? Because 1 times 12 is still just 12. So the factors of 12 that add to 13 are 1 and 12. And we'll need to both be negative to make that negative 13 in the middle, and then that negative will redistribute and get me everything else. Again, this should be about the speed those go through. This is really just a double check or a methodology check in general, but you should be able to get through a lot of these. All right, up next, this is where we start seeing some special stuff, but the idea here that I'm going to emphasize is a 2 to 1 to 0 relationship. So I see a 2, 1, 0 for my x's. On the other side, I see a 2, 1, 0 for my y's. Now, I also see factors of 20 that add to 9, and I know that those are 4 and 5. So let's go through that. Sorry, x plus 4. I'll leave some space here. X plus 4. X plus 5. Now, this is not a correct mathematical way of explaining it. The by grouping will show it, so really you owe it to yourself to split this 9xy into 4xy and 5xy and see why what I'm going to show up is the answer. But more so what I'm going to say is, as long as you see a 2, 1, 0 relationship and a 2, 1, 0 relationship, think about it this way. When the 2, 1, 0 starts on the left, the 1 of the bunch, the single x, ends up being what you put in parentheses. And on the right-hand side, because the 2, 1, 0 started, on the left-hand side, because the 2, 1, 0 started on the left, so my x's go on the left. Now the 2, 1, 0 starts on the right. Guess where your y's go? On the right. Please, please, please go through the full by grouping process. Split that middle into plus 4xy plus 5xy. See why this is your final example, or final answer, and how it comes from this example. But really, we're in the review mode here. So, up next, this one's kind of wacky, but there's still a 2, 1, 0 relationship. It's just that it goes 4 to nothing, but that's still 2 to 1 to nothing. So we're still good to work this out. Now, from there, 15, 19, and 6 don't share any common factor. So I need to do some sort of by grouping. 15 and 6, what do those multiply? 15 times 6. 15 times 6 is 90. Factors of 90 that add to 19 Well, there's 1 in 90. There's 2 in 45. There's 3 in 30. 4 doesn't work. 5 works. It's 5 in 18. There's 6 and 15. That's where we got it from. 7 doesn't work. 8 doesn't work. But 9 works, and we get 10, and those add to 19. So we are going to do this by grouping. But I am going to say there is a way to kind of shortcut the answer, but I'm going to let you figure out how that works. So this is what I was recommending before, is even though that thing in the middle looks different than what I normally see, I know that the 9 and 10 that I found have to be made up of n squareds as well, because that's how I get what's in the middle. They both have to be negative to make the negative 19, and I play the by grouping game. These share a 3n squared. I'm left with 5n squared minus 3. Again, redistribute that, see how that works. How do I get a match out of these two? How do I make positive 5 out of this? Positive 5n squared. Well, I take out a negative 2. So I double negate and get 5n squared minus 3. Now the 5n squared is shared. Minus 3 is shared. I'm left over with a 3n squared minus 2. Very, very interesting. Honestly, 21 I'm going to skip over. We did it in class, but you're really not going to see anything like it. I just wanted to show it to you there. But can I help myself? No, I can't. We should go through it. Sorry, I changed my mind. I should be good. It's late, and I want to go to bed. But we're here to learn. So here we go. There's 1 in 72. There's 2 in 36. There's 3 in 24. That's where we got it from. Which one will add to make 22? Well, that's 73. That's 38. That's 27. Not there yet. What about 4 and whatever that is? 72 divided by 4. Leaves me with 18. Oh, and guess what? Those add to make 22. So, here's what we're going to do. We're going to, this is a different way I did it than in class when we did. But we're going to split the middle. There's a negative 4 t plus 2. I'll write my t's with underlines to kind of make them look a bit different. There's a negative 18 t plus 2. And the plus 3. Now this is wildly different than what I did in class. We used a substitution principle, but it still works. What's shared here? Well, there's a 4 and the t plus 2. And what am I left over with from these first two? I'm left over with a 6 and a t plus 2, as well as a negative 1. Up next, how do I make a match? How does this become 6t plus 2 and minus 1? I take out the negative 3, and I'm left with the 6. Oh goodness. T plus 2 minus 1. Sorry that was starting to bleed together. But now look at it. What do I have? I have in parentheses, I've got a 6 t plus 2 minus 1. And then I've got what's left over, a 4t plus 2 minus 3. And there we go. Now your last step there is you should technically distribute that 6 to this little inner part, the 4 to this inner part, and let's see what we get. If I do that, 6 to that inner part will be 6t plus 11. Careful. That'll be 4t plus 5 if you work that out. So although this initial question looked incredibly ugly, the final answer, by essentially exploiting that the t plus 2 is going to tag along and writing it and being okay with nested parentheses, we're able to avoid a lot of the difficulty of this problem and still get the correct final answer as our factored form. Again, this is different than what we did in class, and so look maybe to what you wrote down then. Just see the differences between the two. See that they still end up playing out the same. Finally, for 22, And in our next video, we'll introduce the special product ideas. We've got one more by grouping question. I see 18, 27, and 4. They don't share anything, so we are doing by grouping. I've got 18 times 4 is... Oh wait, I just figured that out. 72. I need factors of 72 that add to 27. And I can see them right there. There's 3 and 24 because I already was working that out before. Right? It's what we just did in the last example. We had 72. We're still just listing out those factors. I just noticed they make 27 earlier than rewriting it all. So there's the 18x squared. Now you're going to see why the xy that we had before works, because we actually have by grouping to do. We have a 3xy. We have a 24xy. And we have the 4y squared. Now, both of these need to be negative, and let's see what happens. In the first two, they share a 3x. We're left with 6x. We're left with negative y. How do I make a match? I take out a negative 4y, and that would leave me with 6x minus a single y. Again, this part's probably the most crucial. Redistribute it. That makes 18x squared. That makes negative 3xy. This makes negative 24xy if you do some reordering. This makes positive 4y squared if you do some reordering. Now what's shared? The 6x minus y. What's left over? The 3x minus 4y. And we're done. So, what I wanted to emphasize though is notice that again the 2, 1, 0 pattern means the 2 with the 1 ends up on the left hand side. If it goes 0, 1, 2, or again 2, 1, 0 from the right, then that thing ends up starting on the right. So kind of interesting the way that works out. And I'll see you later for the rest of chapter 6.